Hello everyone, I welcome you to this meeting. Last time we talked about the normal distribution. We were discussing the standard normal distribution. But to remind you what we have so far covered, we said that the normal distribution has the probability density function given by f of x is 1 out of sigma times the square root of 2 pi, then e to the minus x minus mu squared divided by 2 sigma squared. And this is defined for minus infinity, less x less infinity. Okay, we say that if x follows the normal, then we write this x follows the normal with the meaning mu and then variance sigma squared. So we also say that if mu equals to 0 and then we have sigma is equal to 1, then we have a special normal which we give a letter z, and this follows a normal with mean 0 and then variance 1. So we say that to find the probabilities, we use tables, but you know, the reason why we use tables is this function right here is very hard to integrate. Yeah, if you're gonna do the integration, then that function is going to be really so hard for you. So what do? We use tables. But I want to show you today that we can use a computer to generate that curve, which we call the normal curve. So I'll go ahead and stop sharing my screen right here. Then I show you what we do and how we do it. Okay, let me stop sharing. So let me go to my computer right here and I share my screen. Do I have, which function do I have? So if I do that, let me go, okay, so I will not share. Let me stop the recording for a while. Okay, this is what I have on my screen. I have a program called MATLAB. You know, MATLAB is a programming language. And what I want to do, I want to plot the normal, the probability density function for x's from -4, increasing in steps 0.001 up to 4. So this is what I'm doing. I have mu and sigma. So I'm using f for the mean. So, you know, for a standard normal, the mean is equal to 0. So my a is equal to 0. And then b, which I'm using for the standard deviation, b is equal to 1. Okay, I don't need this. Okay, I was doing this for my own things, but I want to show the function. You know, we have f of x is equal to, okay, let me write this function. So I have y is my function, okay, which is f of x. It is a function of x, okay, and it is 1 divided by sigma root times the square root of 2 pi. So sigma is b, okay, times the square root of 2 pi, then times exponential of x minus mu, okay, squared. Because we are dealing with a vector, we have so many values of x. This is how we do it. It is how to square a vector. You have to use a dot, you have to use a full stop, and then raise it to squared, divided by 2b squared. I can go ahead and square b if I want. I can go ahead and say, okay, divided by this squared. But you know, b is equal to 1, so squaring it will not affect anything, okay? So I can just write 2b or 2b squared, whatever I need, whatever I do, it will give me what I want. Okay, so I'll go ahead and plot this function. Let me begin by commenting out this part, then I'll explain to you later what that is, okay? So I've commented out, it will not display. Okay, now, if I go ahead and run this program, okay, let's see what you get. We get this function, okay? We get this function, and if I'm to show you the function, really, to be something like, okay, I don't know whether you can see the function or I need to stop this and then, okay, let me stop screen share, then I show that function because it may not really display on your screen. It may not display the way I'm seeing mine here. So let me stop sharing, okay. So I'll go back here and show the function which I plotted. Okay. This is the function that I get, okay, when I plot using a computer. You can see the normal curve. We say the normal distribution curve is barrel shaped, you know. It is barrel shaped. it takes this kind of shape, which is the shape of a bell. And this is the standard normal with the mean 0, okay? The area on the left of the mean and the area on the right of the mean is 0.5. So the total area is 1, okay? So we get that. But what if we want to get the probability between 0 and a particular value on this other side? What do we do, okay? Let's see how we go about that. So how do we get that probability? So to find the probability between 0 and the positive side, we can do the integration, yes, but I'm not going to do the integration here. What I'm going to do, I'll use a built-in command. You know, MATLAB is so rich, it's a big software, okay? We have a toolbox for statistics, and I can use P for the probability. Let me use capital P, okay? Which is normal space between, okay, so I want to get the area between 0 and 2. Let me begin with maybe 2.345, something like that, okay? So if I go ahead and run this program, you will see the shaded part is the area, okay? I have to stop sharing the first part to show the second part. So I have to come back here and share the screen to show you what I got. So this is what I have if I plot, you know, use my command, which is the norm spec, okay? I get the probability between 0 and 2.345, okay? This is the shaded area. And I have the value here as 0.49049, that's the probability. So MATLAB can give me anything, but because, you know, most people don't have access to this software, what we do, we have tables, okay? The standard normal tables, cumulative normal tables that we can use to read the probability. So the next few lessons I will be struggling to teach you how to use these tables. The moment you master the tables, then we start solving problems in normal distribution. All right, so let's get there and see. Stop sharing.